Well, hi there, this is Mrs. Sharp, and I'm going to take a moment to go over your LTA that you took on 7.2, classifying reactions and predicting reactions, and 7.4, using the law of conservation of mass to balance equations. So the thing is, if you were in 6th and 7th hour, this is the exact same format you saw on your LTA. If you were in 3rd, 4th, or 5th hour, your questions were a little jumbled up, but you had the same questions just in a different order. So they will be presented a little bit differently here, but it's the same concepts, so that will benefit you too. So in this part here, 161 through 170 on this particular version, we've got classifying reactions. So I'm going to go through one at a time, tell you the answers, and explain why. So the first one in 161, I've got sodium over here, and it looks like it's just switching partners. So over here it's with bromine, over here it's with phosphate, so that makes that a double replacement reaction, or a D. Number 162, I've got a single element magnesium, and it looks like that is switching places with the iron, leaving iron all by itself as a lone element, which makes that a single replacement, C. Number 163, I have PbSO4, which is just falling apart into two smaller pieces, so just one reactant here. That makes that a decomposition B. Number 164, I have a free element iodine, and iodine is kicking out the hydrogen over here, so another lone element, and then two compounds, dinitrogen hexaiodide and nitrogen trihydride. That's a mouthful. So with this free element and the compound and the switching of the iodine and the hydrogen makes that a single replacement, C. Number 165, I have two small compounds coming together to form one big compound. That's a synthesis composition, A. It is not also a combustion because it is not reacting with O2 on the reactant side. Number 166, I have oxygen as a reactant, so that does make that a combustion, E. However, it is not a synthesis as well because I have more than one product. Number 167 is a double replacement. Sorry, I'm getting a little crazy with my cursor there. Double replacement, my hydroxide, my OH over here, is switching partners. Here it was with calcium. Now calcium is with the anion sulfate over on this side, and the OH is with the aluminum on the product side. Number 168, I see two things coming together to make one product, which makes that a synthesis composition, A. However, this one is also reacting with oxygen, so it is also a combustion. Number 169, this is one reactant falling apart to make two products, which makes this a decomposition, just one reactant. And then finally, number 170, I've got potassium switching partners. Here it's with carbonate. It's going to grab barium's partner, so I'm going to have potassium chloride now, and barium gets potassium's partner, carbonate, making that a double replacement. In the next section, we have some predicting of products. Now, number 171, mercuric oxide, is the only reactant making this a decomposition. So you need to choose what it's decomposing into. And here are your choices. The correct choice is C. Mercuric is not appropriate because that indicates a charge, and mercury would just be an element. Same with oxygen. Oxygen is an element, so it wouldn't be oxide, it would just be oxygen. So 171 is C. Number 172 is a single replacement reaction because I see a single element chlorine plus a compound sodium bromide. So I need to check what chlorine is going to replace. Since chlorine is a non-metal, it will try to replace bromine. So I check my activity series. Chlorine is more reactive than bromine, so this reaction will happen. Excuse me. And so I should get B, sodium chloride plus bromine. Number 173 is also a single replacement because I have a free element silver plus chromium oxide, a compound. My free element silver is a metal, so it's going to try to replace chromium, or in this case, chromium with a +2 charge. However, silver is lower than chromium on the activity series, so this should be C, no reaction. It's not reactive enough to kick out chromium. Number 174 is another single replacement. I have calcium metal all by itself, attempting to replace iron, the metal in this compound. As it has a charge, it's ferrous. So those two will switch places. I should have calcium sulfide, but not plus ferrous. That would indicate a charge. So the answer is D, calcium sulfide plus iron. Since it's all by itself, no charge. Number 175 is a double replacement. So the partners should switch places, getting potassium chloride plus ferric sulfide. So that is both A and B. So we need to look at the down arrows in the aqueuses. If you check your activity series, ferric sulfide is insoluble, so it should be a precipitate, and potassium chloride dissolves in water, making it aqueous. So your answer is B. Number 176 we made some corrections on. We made this arrow right here aqueous. If calcium hydroxide and hydrogen bromide switch partners, I get calcium bromide and then hydrogen hydroxide, which is water. So the correct answer is C, because water is a liquid and calcium bromide is aqueous, which we switched this arrow to. So that's it for our predicting. For 7.4, we had some coefficients that belong in the blank, so I'm going to attempt to write those coefficients in as we go with some, looks like blue. When I balance this reaction, I have 1 carbon, 4 hydrogens, so I need to make this a 2 to get 4. And then I have altogether 2 oxygens here, plus the 2 here, so 4 altogether, so that would be a 2. Doesn't matter, my coefficient is 2 here, so that's going to give me an answer of B. Number 178, I'm going to have 2 chlorines over here, which means I need to make this 2. Because I have 2 NAs, that would make this a 2 as well. So your answer for 178 would also be B. Number 179, I need to balance my oxygens first. So if I make this a 2, that's going to give me 6 oxygens, which makes this a 3. And then I'm going to have 4 aluminums over here. So my correct coefficient is 2, which means I have another B as my answer. Number 180, 2 nitrogens, so I'll fix that over on this side. Now I have 6 hydrogens, which means I need to make that a 3. Since that is a 3, the correct answer is C for number 180. Number 181, I can see that my carbons are 8 here, so I'm going to turn that into an 8, make sure that stays that way. My oxygens are 8, so I'm going to make that an 8 over here. Now that gives me 18 plus 16, which is 34 hydrogens, so that would make that 17. So everything's balanced, meaning this is going to be 8, so our correct answer is AD for number 181. For number 182, our carbons are balanced already. However, for our oxygens, I need to make it so that I have a total of 6 over here, so I can do 3 and 3. Now I have 3 carbons, 1 iron, and then the 3 oxygens plus 3 more makes 6, and 3 times 2 is 6 over here. That means your answer is, for that one, C, coefficient of 3. Number 183, I first replaced my water with HOH, since I have an OH blobby over here and water on this side. When I do that, my leads balance. I need to, and my SO4s do not, so I need a 2 there. And that gives me 4 hydrogens, so I need a 4 here. So 4 hydrogens and then 4 OH blobs, which I have. So my coefficient in the blank was a 2. This one. Which, oh, I'm sorry, is a B. Okay, number 184. ALs are balanced, CLs are not, and H's are not. So what I see immediately here is that I have 2 H's and 3 Cl's, so that's not going to balance here. So the common multiple there is 6. Whoops. So that I can easily make Cl6 by multiplying that by 2, and I can easily make hydrogen 6 by making that a 3. That does, however, mess up my aluminums, so I'll fix that. This was the coefficient of 6, which is AB. Number 185. This one was messy because you had calciums in 2 spots and you had your PO4 blobs with a hydrogen. So what I did here is I took this H2, and since there were 2 of them, I knew that was 4, and I just moved him up front. H4. Whoops, that's a 3. H4. So then I could deal with my H4 and my PO4 blobbies. So I have 2 and 2 for our PO4s. My hydrogens, I need 2 more of those to make 4. So I have 4 over here. And then my calciums, there are 3. And now I have 2 sulfates, so I need to make this a 2. So now I have 2 plus 1, 3 calciums, which I have over here. 2 PO4s, 2 PO4s, and 4 H's. So I'm good. So my coefficient again is 2, just letter B. Last but not least, we've got our H3PO4 and HCl. I'm going to balance my Cl's first, which makes this a 5. Oops. This is a 5. So that gives me 8 H's altogether, which would make this a 4. And then 4 O's, which I have, 1 P, which I have. Everything is good. 5 makes that letter E.